Okay, so you just saw a video on how to use Desmos and how to graph those polynomial functions, those power functions. This short part of the video is going to be about symmetry, and I'm going to reinforce the idea that I talked about earlier on end behavior. Okay, so I've got two grids here. I'm going to graph by hand the two functions, the first two functions from our table that we have to graph in Desmos. Okay, so I'm going to graph y equals x, just a rough sketch. So we've got y equals x right here. We've got a straight line passes through the origin. Now we talked about end behavior. Remember we talked about end behavior? We says, well, as x goes out forever, we want to, what happens at the end, which it always keeps going, but we want to talk about kind of end. So we say as x goes out to infinity, as it goes out, what is the function doing? Is it increasing or decreasing? If it's increasing, and this one is, it's going up to infinity. So we say y goes up to infinity. It goes up. And then we say, well, let's look the other way. As x goes out to negative infinity, what's happening to the function? As x goes this way, when we go from right to left, this function is going that way, in downwards. So we say y goes to negative infinity. So that's our end behavior. When we talk about symmetry, though, there's no kind of like, it's not a flip. It's not kind of like this part of the function has been flipped across the axis, because it would be down here if that was true. And it's not flipped across here. There's no line I can cut this thing by, and it's symmetric on both sides. So, but what there is a symmetry in this function such that if I took this part of the function and I rotated it all the way around, it would fall on, and I rotated about this point right here, it would fall on that line right here. So instead of being a line, I cut it and it's symmetric on both sides. It's a rotation symmetry. So we call this point symmetry. Okay, we've seen symmetry before in other types of functions. Like if I graph the second function from our list by hand, our most basic parabola, y equals x squared. Our end behavior, if we just talk about that first, as x goes out to infinity, the y, as it goes out, it still goes up, so y goes out to infinity. As x goes to negative infinity, we go that way. The y goes up. As we go that way, it's going up, so y goes up to infinity, to positive infinity. So that's our end behavior for this graph. That's what we would write in the table. Now this one has this kind of line where I can cut it, right? I can cut it right down the y-axis, and this graph is symmetric about that line. There's a flip across that line. If that exists in a graph, we say it has line symmetry. So there's two types of symmetry. We've got line symmetry, like we've talked about in grades 10 and 11. And this has to do with, one example is the parabola. We've also got point symmetry, where we could rotate it around a point and it flips, and it would rotate right on top of the other part of that function. So that's what I'm looking for. We're looking for those two types of symmetry when we talk about our power functions.